Section 8.5, Reducing Quadratic Equations. So what we're going to do here is we're still going to solve equations, and we're still going to use methods like factoring, quadratic formula, and stuff like that. But the equations look a little tricky when you first look at them. For example, x to the fourth minus 9x squared plus 8 does not look like your typical quadratic equation. And actually, you could say it's a fourth power equation. But what we can do is we see that it does look similar. We have a something to the fourth and a something squared, and then a constant. So it looks kind of like ax squared plus bx plus c, but it's missing some information. So what we can do is we can use what's called u substitution, or any letter, but I'm just going to use u. And so if I say u equals x squared, then everywhere I see x squared, I can write u. So x to the fourth is x squared squared, so it's u squared, minus 9, and x squared is u, plus 8. So there's u substitution. Once you get to this stage, it's super easy. It's actually a guess and check. Multiples of u squared are u and u. Multiples of 8 that add up to negative 9 are negative 8 and negative 1. And then we can set each piece, so u minus 8 equals 0 and u minus 1 equals 0. So u equals 8, u equals 1. But we didn't ever want to solve for u. Back in the original, u meant nothing to us. So what we have to do is now, once we have solved for u, plug it back in for what u is. U is x squared. So u is x squared equals 8, and x squared equals 1. So at the very beginning, we get into u's, we solve with u's, and then we get back out of them at the end. So we square root both sides and see that x equals plus or minus square root of 8. If I factor tree, it's 2 and 4, 2 and 2, 2 rad 2, and square root of 1 is plus or minus 1. So look at that for a minute. So I'll say it again here. At the very beginning, we need to find what this term is, and it comes from ax squared plus bx plus c. And we're looking for what the x is. So very commonly, we can just go straight to what this middle term is, and that's what we let u be. That's my shortcut hint for you. Let's look at another one. Take a moment, write that down, pause it, and come back. Now what we see here is we see some term, these parentheses squared, minus the parenthesis minus a constant. Oh, and what we're doing here, we can find the x-intercepts. Finding the x-intercept is the same as solving, except for putting your answer in intercept form in the end. So we should see that we want to let u be what is being squared and what the normal number is. So u is going to be x squared minus 1. That's what the squiggly is. So now we can rewrite it. We have u squiggly squared minus u minus 2 equals f of x, or in this case 0. To solve, go ahead and factor. Multiples of negative 2 that add up to negative 1 are negative 2 and positive 1, I believe. So u equals 2 and negative 1. But that's not what we're looking for. We're looking for what x equals. So we plug it back in up here, and we say x squared minus 1 equals 2. And x squared minus 1 equals negative 1. And this is what u was. And now we just solve. Add 1, x squared equals 3, x equals plus or minus square root of 3, x squared equals negative 1 plus 1 is 0, x equals 0. And remember at the beginning it asked for x-intercepts, so we need to put those in intercept form. So our first x value is positive square root of 3, y is 0 at the intercept, y is always 0 at an x-intercept. Second one, negative square root of 3, comma 0, and the last one is 0, 0. So those are the 3 x-intercepts we have here. Okay. Now our next one, number 3, is x minus 3 square root of x minus 4 equals 0. Now again, I don't actually see anything squared, but if you think about it, this square root of x, if I were to square it, the square root and the squared undo each other. Hope you can see that. And you're left with x. So u, or you can use my shortcut and go straight for u is that middle term, is square root of x. So if u is the square root of x, then what's u squared? Well, squared u is u squared, square root of x squared is x. Just like the square root of 3 squared is 3. So now we have u squared, because that's what x is, minus 3u minus 4 equals 0. Go ahead and factor. Please pause if you need to. You should be a master at factoring by now. U equals 4 and negative 1. But we don't want to know what u is, we want to know what x is. So u is the square root of x equals 4, and the square root of x equals negative 1. To undo the square root, we square both sides, 16, and x equals negative 1 squared is 1. Now, just like in the problems before, when we have radicals in the problem, we have to check. If you notice, I didn't check on 1 and 2, all those solutions will work. But as soon as I get a radical introduced, I do need to check. So I'm going to go ahead and plug 16 in. 16 minus 3, square root of 16 minus 4. 16 minus 3 times 4, square root of 16 is 4. 3 times 4 is 12. 16 minus 12 is 4. Minus 4 is 0. Now let's plug 1 in. 1 minus 3 times the square root of 1 minus 4. So we have 1 minus 3 times 1 is 3 minus 4. And that is not 0. So that solution does not work. Our only solution is 16. Pause it if you need to. So what we're going to do here is we're just going to do a couple different types where I can give you a hint at what your u's will look like. So again, it's going to be very helpful for you to re-watch these videos, especially the night before a test or quiz, so you can get a little refresher on what u is. Here, we have something squared and something to the first. So our something to the first is m to the negative 1. And then if u is m to the negative 1, u squared is m to the negative 2, because negative 1 times 2 is negative 2. So here we have 2, m to the negative 2 is u squared plus u minus 15. As you'll see, once you do this very first step, these are some of the easiest problems we've done in quite a while. Factor. Multiples of 2u squared are 2u and u. Now this one, or you could use our modified grouping method. There's not a whole lot of choices if we wanted to guess and check. Multiples of 15 are 5 and 3. So we have, you should be able to figure this out. I'll just tell you, minus 5 plus 3 does work out. If you're not sure, you need to FOIL to get back to check. Okay, so 2u minus 5 equals 0. I'm just showing my steps for you here. U equals 5 halves, and u equals -3. You shouldn't need to see that step. But again, u isn't what I want. M is. U is m to the -1 equals 5 halves, and m to the -1 equals -3. Now don't forget that m to the -1 is really 1 over m. So here we have a fraction equals a fraction. We can cross multiply. 1 times 2 is 2 equals m times 5 is 5m. M equals 2/5, and here 1 equals -3m if I move the m up, and divide by -3. M equals -1/3. There were no radicals introduced. We don't really need to check, but of course you're always more than welcome to. Okay. Number 5, t to the 2/5 minus t to the 1/5 minus 2 equals 0. So what's being squared here? Well, if I took this apart, I would have t to the 1/5 squared, which is this term here, so you could always use the shortcut. So in this case, u equals t to the 1/5. So then here's u squared minus t to the 1/5 is u minus 2 equals 0. Please pause. You should be able to finish this from here. And we get u minus 2, u plus 1 equals 0. U equals 2 and -1. So t to the 1/5 equals 2, and t to the 1/5 equals -1. And remember, to undo something to the 1/5 power is to raise it to the 5/1 power, or the 5th power. So 1/5 to the 5th cancels. So t is 2 to the 5th, which is 32, and t, these cancel, is -1 to the 5th. A negative number to an odd power stays negative. Here's the last one for you to try, that I will be checking 4 points in class. T to the 4th minus 7t squared plus 12 equals 0. Please go ahead and give that a shot.